Ever wondered what your body is capable of when faced with extreme conditions? Our bodies are designed with incredible survival mechanisms, adapting to everything from hunger to extreme cold. Let's dive into the science behind survival mode. First up, hunger and starvation. When food is scarce, your body reduces its metabolic rate to conserve energy. Stored fat becomes the main fuel, and prolonged fasting even breaks down muscle tissue for amino acids. Hunger triggers hormones like ghrelin to increase appetite and cortisol to release energy stores. The body adapts by slowing down to preserve vital functions. Next, extreme cold environments. In cold environments, your body maintains core temperature by diverting blood from extremities and increasing muscle activity, like shivering, to generate heat. Hormones like adrenaline and thyroid hormones boost heat production, and over time, people can develop higher metabolic rates to generate more heat. By focusing energy on the core and triggering shivering, the body minimizes heat loss and prevents hypothermia. Next, high altitudes. At high altitudes, oxygen levels decrease, causing the body to work harder to supply oxygen to organs. This triggers increased breathing and heart rate. Over time, the body produces more red blood cells to improve oxygen transport. It also increases hemoglobin levels to boost oxygen carrying capacity, which helps people adapt to lower oxygen levels. The body gradually acclimates by enhancing oxygen delivery, allowing it to function with less available oxygen. Next, dehydration. When water intake is low, the body releases antidiuretic hormone, ADH, to conserve water by reducing urine output and increasing water reabsorption in the kidneys. The body prioritizes hydration for critical organs and triggers feelings of intense thirst. It can also pull water from cells and other areas to maintain blood volume. By conserving water and prioritizing hydration for vital organs, the body tries to prevent dehydration-related complications like low blood pressure. Next, extreme heat environments. In high temperatures, the body cools itself by sweating and increasing blood flow to the skin. This helps dissipate heat, but also leads to water and electrolyte loss. Over time, people can acclimatize to heat, producing sweat with fewer electrolytes and increasing blood volume to maintain circulation and prevent overheating. By maximizing sweat efficiency and blood circulation, the body works to keep core temperature in a safe range, reducing the risk of heat exhaustion. Next, prolonged stress or trauma. In life-threatening or high-stress situations, the body releases adrenaline and cortisol, enhancing focus and energy to support fight-or-flight reactions. Chronic exposure to stress can make the body adapt by desensitizing to stress hormones, but prolonged stress can eventually take a toll on physical and mental health. Short-term stress responses improve survival chances, but long-term exposure requires coping strategies to prevent burnout and stress-related conditions. Next, oxygen deprivation underwater. When submerged underwater, the body activates the mammalian dive reflex, which slows heart rate, constricts blood vessels, and diverts blood flow to vital organs like the brain and heart. This reflex allows the body to conserve oxygen by prioritizing only the most essential functions. Over time, with training, divers can expand their lung capacity and tolerance for higher carbon dioxide levels. The dive reflex allows the body to conserve oxygen and prolong survival underwater, a natural adaptation observed in mammals like seals and dolphins as well. Next, severe pain and injury. During severe injury or pain, the body releases endorphins, natural painkillers, to numb the sensation and allow survival actions. Adrenaline can also temporarily mask pain, enabling escape or action. In survival situations, endorphins can provide a temporary boost of resilience against pain, helping individuals cope with severe injuries in the short term. This natural analgesic effect is vital for survival, allowing people to push through pain in emergencies, although chronic exposure to pain can eventually overwhelm the system. Next, sleep deprivation. When sleep is limited, the body tries to compensate with microsleeps, brief moments of sleep lasting just seconds that can occur even while awake. The brain also increases adenosine, promoting the pressure to sleep. Over time, the body can somewhat adapt to shorter sleep patterns by entering deeper sleep phases faster, although extended deprivation severely impacts health. Short-term adaptations to sleep loss help the body function in emergencies, but prolonged sleep deprivation leads to cognitive and physical impairments. Next, infections. During an infection, the body raises its temperature, triggering a fever to create a less hospitable environment for pathogens. Fever also boosts immune cell efficiency. The body's thermostat, hypothalamus, increases temperature to slow down pathogen reproduction, while white blood cells increase in activity to fight off infections more effectively. Fever is a controlled survival mechanism that enhances immune function and inhibits pathogens, though excessive fever can be dangerous. Lastly, sun exposure and tanning. In response to ultraviolet (UV) radiation from sunlight, the skin produces more melanin, which darkens the skin to protect deeper layers from damage. Increased melanin helps shield the skin from UV rays, reducing the risk of DNA damage and skin cancers over time. People living closer to the equator naturally produce more melanin due to higher sun exposure. Tanning is the body's natural way of shielding skin cells from UV damage, though overexposure can still lead to harm. Isn't it amazing how our bodies are wired for survival? However, these adaptations are not meant for prolonged use. Long-term exposure to extreme conditions can lead to health complications, underscoring the importance of balance and adaptation. Stay curious and keep exploring the wonders of human biology.